Let's see the various types of scheduling algorithms we have. Okay, we shall see each scheduling algorithm one by one. Before that, the set of all scheduling algorithms we have can be classified into two types. Okay, preemptive scheduling algorithms and non-preemptive scheduling algorithms. Okay, the name itself suggests what they are actually, right? For example, what is meant by non-preemptive scheduling algorithm is, let's come here. See, let us assume this is our RAM, okay? This is our RAM, and we, as of now, we have four processors named P1, P2, P3 and P4, okay? Now, what non-preemptive scheduling algorithm says is, in case if one of, let us assume we have only three processors, okay? Let us assume we have only three processors as of now inside the RAM, okay? Now, how non-preemptive scheduling algorithm works is, in case if one, let us assume P1 has started, P1 has been scheduled to the CPU, okay? Now P1 is in running state, which means it is being executed by the CPU right now. Now during this time, let us assume there is a process named P4 which came into the RAM, okay? And let us assume the priority of P4 is higher than that of P1, okay? Priority of P4 is higher than that of P1. Now, should I preempt P1 and start with P4, or should I continue P1 as it is? That is the question, okay? In case of non-preemptive scheduling algorithm, we will never preempt a process until it is completed. In case if we have started it, okay? In case if we have started it. For example, we have actually started P1 here, right? Before P1 has arrived. Now even though P4's priority is greater than that of P1, we will still not preempt P1 because it is a non-preemptive scheduling algorithm. Okay, only after the completion of P1 we will check which process among these has the highest priority and then we will pick. Okay, but once a process has been once a process has started execution, we will never preempt it until completion. That's what non-preemptive scheduling algorithm means. Okay, now what is meant by preemptive scheduling algorithm? In preemptive scheduling algorithm, we can preempt the process, right? For example, if P1 is being executed by the CPU and in case, let us assume P4 has come into the RAM and priority of P4 is greater than P1. Now in this case, what we will be doing is we will preempt P1 and then we will schedule P4, which means the scheduling algorithm will schedule P4, okay? So that is the difference between preemptive scheduling algorithm and non-preemptive scheduling algorithm. In non-preemptive scheduling algorithm, in case if we have started execution of a process, we will never preempt that process until completion. Okay. Fine. Now have a look at this point. CPU scheduling algorithms are applied only to processes which are in the ready state. Okay. See, let us assume there are some processes inside the RAM. Okay, we have processes P1, P2, P3 and let us assume process P4. Okay, now we know that any process in the RAM can be either in ready state, it can be either in ready state or it can be in IO state or it can be in running state, right? Let us assume process P1 is in running state. Okay, process P1 is in running state means P1 is currently being executed by our CPU. And let us assume processes P2 and P3 are in ready state, which means processes P2 and P3 are inside the RAM, but they are neither undergoing IO nor they are being executed by the CPU, but still they are waiting inside the RAM idle. Okay, fine. Now let us assume process P4 is in IO state. Fine. Now my question is, as of now, let us assume we are actually having non-preemptive scheduling algorithm. Okay, non-preemptive scheduling algorithm, and one more assumption is that the priority of process P4 is greater than both P2 and P3. Okay, priority of process P4 is greater than P2 and P3. Now, as of now, P1 is currently being executed by the CPU, so there is no chance of preempting process P1, right? That's what we mean by non-preemptive scheduling algorithm. Doesn't matter what the priority of P1 is, in case if we have started P1, we will never preempt it until completion. Fine. Let us assume process P1 has been completed. Okay? Fine. We have already seen that whenever a process has completed its execution, that process will be completely removed from the RAM. Okay, the process has been completely removed from the RAM. Now my question is, now our scheduling algorithm might have to schedule one of the process to CPU, right? That's what our scheduling algorithm will do, which means now my question is, which process will our scheduler schedule to the CPU? Okay, among these three processes, which process will our scheduler schedule to the CPU? Now you might say that process P4 will be scheduled by the scheduler because priority of process P4 is greater than P2 and P3. But that is actually not correct. Okay, why? See, process P4 is in IO state. Okay, what does it mean? Process P4, in order to continue execution of process P4, we might have to do some IO, which means process P4 needs some data to be read from some of the IO devices, which means it can be either hard disk or it can be printer or any IO device is fine. Okay, so process P4 might have to read something from one of the IO devices. Only after it is being done, it can further proceed with the execution. Okay, so what I really mean by this is, scheduling algorithms will only take processes which are in ready state, and only within these processes it will select one of them, okay, depending on priority. Okay, it will never consider process P4 because process P4 is in IO state. Let's see, let us assume scheduler schedules process P4. Okay, scheduler schedules process P4 to CPU. Now can CPU execute P4? No, right? Because P4 needs to undergo IO. Only after that it can actually proceed with the execution. So what I mean by this is, CPU scheduling algorithms are applied only to processes which are in the ready state, and processes which are in IO state will be blocked, and so those processes will not be considered by scheduling algorithms while scheduling. Okay, and maybe 2 or 3 videos back I have already told that if a process is in IO state, see, we have seen the various states of a process, right? We have seen waiting state, IO state and all this. I have already told that if a process is in IO state, we can also say that it is in blocked state. Okay, this is the reason for this. Okay, if a process is in IO state, we can also say that it is in blocked state, because IO state and blocked state both are same. This is because if a process is in IO state, then that process will not be considered by the scheduling algorithm. Okay, then process will not be considered by the scheduling algorithm. Fine. Okay, so among the processes which are in ready state, the scheduling algorithm will schedule the processes. Fine.